All right, we're going to try the last question from 2018, the Latin square. This is a great question. It's got a whole bunch of different aspects to it. So first off, we have to just kind of look at this array tester class and figure out what we're working with here. I see that we're going to write a method in part A called getColumn. Okay, and then I also see that we're writing a method in part B called isLatin, but in between, I see these two methods here, hasAllValues, containsDuplicates. So when we see this implementation not shown, more than likely, we're going to have to call these methods, right? I don't see any instance fields or constructors or anything here. These are static methods, so they're kind of standalone, but we will have able to help us these two methods here, hasAllValues and containsDuplicates. So before I leave here, I'm going to try to figure out, like, what do these methods do and what do I have to do to use them? So hasAllValues says that it's going to say true if two arrays have the same values, okay, false otherwise. They have to have the same length, okay, to use this method, and it won't change them. And it gives this back to you as a Boolean. So you give it two one-dimensional arrays of ints, same length, and it will tell you true if they have all the same values, false if they don't. Okay, it contains duplicates. If I give it a one-dimensional array of ints, it will tell me true if there are any duplicate values within that one-dimensional array, and it will tell me false otherwise. As of right now, I don't really know why I would need these methods, but it'll probably become clear to me as I read on. Okay, and then if we look at part A, so this is getColumn. If you took my class, we wrote this method probably more than once. So here's an array of ints. It's a matrix. It's got two dimensions to it. If I tell you a column of the matrix, can you hand me a one-dimensional array of all of its values? And just a couple things to note here. This is a static method. We're not given an array. There's no instance field, so we have to create it ourselves. They'll give us a two-dimensional array, a matrix, but we'll have to make an array, put the values in it that we desire, and then return it. Okay. When we make the array, we have to say how big it is. So it's a little tricky, right? They tell you the column index, but it's actually the number of rows that we're interested in, right? Like in this example here, there was 4 rows, and notice that there were 4 values that came out in that 1D array because there's 4 values within column 1. So we'll need a loop to generate those row indexes. Often when we work through a matrix, we have a nested loop structure. Not the case here. They've already told me the column loop, so I only need to write a loop to generate row indexes. The row indexes can actually serve double duty too, because they can actually index our way through the one-dimensional array, which is nice. Okay, so as we start writing our code for part A, like I mentioned, the first thing I'm going to do is generate or declare and initialize a new one-dimensional array to hold these column values. All right, now this array needs a dimension. The dimension is not C. The dimension is something I have to look up by taking the length of the matrix, right? Remember what I mentioned, it's the number of rows that tells me how many values I want to put into this array. All right, at the conclusion of my method, I'll return this array, and in the middle, I need to go through and put all the values in. So starting off here, actually, let's call that variable r just because it represents a row index. So row index 0 would be at the top. We'll finish up with arr2d.length, although we could also use here col.length. They should be equal. Okay, and then in the middle, or sorry, at the end, we'll say row plus plus. So we're going to go to every single row. And when we get there, we'll access our column array, right, which only requires one subscript. And we're going to access a value from arr2d, which requires 2 subscripts. It's a doubly subscripted storage system. So the double subscript over here, this is why I have created all of the R values to pair with all of the C values. Again, no loop required for the column indexes because it was already predetermined. And as I mentioned, you can actually give the R index double duty here. It'll match up with the indexes of the one-dimensional array as well. All right, so if you wanted to, you could actually run the code right now, and part B is just going to, mistake, but in part A, we'll see the one-dimensional array being generated, hopefully. And then we'll go on, and now we're going to try to determine if this is a Latin square. All right, so how do you be deemed as a Latin square? It's got to go through a pretty big series of tests here. So a two-dimensional square array of integers, notice it is square now, is a Latin square if the following conditions are true. So the first row has no duplicate values. All right, well, hopefully you remember from that first page of directions, there was a method called containsDuplicates. So we could call that method and we could hand it the first row of the matrix. Remember, a matrix is simply an array of arrays. So the first row is the array with index 0 within the matrix. Okay, so I'll hand that row to the method containsDuplicates. If it says true, that's actually bad for me, right? I don't want it to say true. So if it says true, it can't be a Latin square. I could just go ahead and return false. Nothing else would matter at that point. Otherwise, if I keep going on, I'm going to take the values of the first row again, and I want to see if they appear in each row of the square. Well, again, they actually gave me another helper method for this. It was called hasAllValues. If I give that method two one-dimensional arrays of ints with the same length, and since it's a square matrix, they will, it will tell me true if they have the same values. I want them to have the same values. So now if it doesn't have all the same values, that's bad. And then I would say false, okay, at any point. I'm still not ready to say true yet, though, because I have to make it through the third bullet point, which takes the first row again and compares it with all of the columns. Since it's a square, they'll have the same dimensions. And I want has all values again. I want it to keep saying true. So all the values of first row show up in column 0, show up in column 1, show up in column 2, and so on until I run out of columns. If I ever see false, I can say false, it's not a Latin square. If I make it through that entire battery of tests without ever seeing a false, then I'll be ready to say true. You have to use the helper methods here. Okay, if you don't, you don't get full credit. So, all right, that's just something we need to be ready to handle as we take our AP test. All right, so I noticed in that problem that first row kept appearing. So I think probably the first thing I would do is just go ahead and make a variable called first row, and I would initialize it to be square 0. Now, why did they change the name of the matrix for part B? I have no idea, but they did. So now I have to refer to it as square. Okay, if you can recall, the very first test we want to do is we want to call up that containsDuplicates method that we just saw. And we want to hand this method one single one-dimensional array of ints. Okay, how do I know that? Well, all right, they were nice enough here to list the signatures again. So right here, containsDuplicates is expecting a one-dimensional array of ints. And it will tell me true if there is a duplicate. Now, if it says true, that's actually bad, right? We don't want a duplicate. So if they come back and say true, we're going to return false, because at that point it can't be deemed as a Latin square. All right, in the next, now obviously here I don't want to say else return true. I'm not ready to say true until I've made it through this entire lineup of tests here. Now I want to take first row and compare it to all the other rows. So row 0 to row 1, row 0 to row 2, row 0 to row 3, and so on until I run out of rows. This is going to require a loop because I don't know how many rows there are. I've already isolated row 0, so I'm really only interested in generating all of the remaining row indexes. Okay, so I could figure that out from square.length. And at this point, what I want to do is I want to call that method up, which was hasAllValues. Okay, how does this method work? Well, all right, according to the signature, the method hasAllValues wants me to hand it two one-dimensional arrays of ints. They have to have the same length, but it's a square matrix, so they will, okay? And it will give me back a Boolean that will say true if they do have all of the same values. Okay, here's the two one-dimensional arrays I'm going to give it. First, I'll give it first row, Second, I will access the square matrix and hand it one of those other rows, starting with row 1. So row 0 versus row 1, row 0 versus row 2, and so on. This time up, I got to be careful here. This time I actually don't want this to happen, right? So, well, I shouldn't say that. I want it to happen. If it doesn't happen, then I'm going to say, you know what, this is not a Latin square. Okay. So if it fails that test, then it can't be a Latin square. It has to keep passing that test for every comparison of row 0 to all of the remaining rows. I want to do the same thing now with row 0 versus all of the columns. And this is why we wrote our method in part A. Part A's method can generate those columns for me as one-dimensional arrays, which is crucial because I will need a one-dimensional array to hand to the hasAllValues method. Okay, so what I need to do then is know how many columns we're talking about. So again, I'll write a loop, right? And this loop is going to generate all of the column indexes. This time I have to start with 0. Last one I didn't because I already had row 0, but I don't have column 0 yet, so I have to go through all of the column indexes. This is a square matrix, so I mean you could get away with putting square length there, or if you just wanted to stick with like column notation, you could say square 0 dot length. It shouldn't matter. All right. We're going to write almost the same line of code here. We're going to say not hasAllValues again, and we're still going to hand it first row. But the difference is now I won't actually go back to the square matrix to get this. I'm going to have to rely on my method from part A. Now, when you call that method from part A, be a little bit careful. What does that method want from you? It wants a two-dimensional matrix, and it also wants the column index. Now, the matrix changed names in part B, so you got to call it by this, what you have access to, which is square, and then this right here would say C, which was my loop variable. And remember, if this didn't happen, that would be bad in terms of this being a Latin square, and we would say false. Now, if we make it through this entire battery of tests, and notice I haven't even mentioned true yet, I'm only checking for things that rule it out. If I make it through all of those tests, then I can say, oh, true, this is a Latin square. And I'm outside right now and the Wi-Fi is not great, so I'm worried about this. Let me see if this is gonna run or not. We may have to refresh here. Sorry about this. We're gonna give it one try and see if this works. It looks like it did work, by the way. So I see the results over there, and it looks like it actually. Oh no, yeah, it did actually run my code finally. But let's see what it says now. And yeah, it worked. All right, believe it or not, I was nervous. No, okay. So notice that we got the two trues. I gave it the same 5 tester cases that were in the directions. So these 2 were Latin squares, and the bottom 3 weren't for various reasons. And yeah, it looks like it's working perfectly. All right. So again, even using those helper methods, that was a lot of code. If you started writing your own code, this would be crazy problem, tons of lines. Okay, so and again, a good logic lesson here, right? We're only looking for one side of the return, the false, and then we're waiting patiently to return true. Okay, all right, so that's a great problem to review with. Even though in 2020 we won't see a two-dimensional array, it's still very emphasizing in methods and control structures. So great problem.